polyurethanes. My subject today is healthy coatings for healthy environments. The frequent pandemic outbreaks are straining the health systems worldwide, and the best defense against such viral outbreaks is to build a strong health system involving hospitals and healthcare facilities. Prolonged outbreaks can lead to the progressive spread of the disease with rapidly increasing service demands, which force the hospitals to operate at the near surge capacity. And in this scenario, it's very essential to minimize the risk of transmission of nosocomial infections to patients, hospital staff, and visitors. So I'll start my presentation. I'll upload it. Hygienic coatings play a very significant role with the rise in the shared spaces acquired infections, which are caused by viral, bacterial, and fungal pathogens. Most of the infections occur by contacting the commonly shared spaces like walls, glass panels, doors, floors, and so on. The floors and walls of a hospital, a healthcare facility, or a pharma or an F&B contribute to a large hosting surface area for pathogens which remain active on floors and walls from days to months. The surface sanitization is a temporary treatment and the residual microbes continue to multiply. While hygienic coatings reinforced with antimicrobial agents do not allow these viruses to replicate and eventually destroy them. What is a hygienic coating? Let's not mess up hygienic coatings with antibacterial coatings. Many people offer antibacterial coatings off their shelves using common biocides like zinc pyrethiones, formaldehyde, chloramines, bisphenol derivatives, metal complexes. These are all normally used as a wet film and dry film preservatives as biocides and fungicides used in waterborne paints which confer antibacterial properties. What I am talking today is not about antibacterial coatings, but about antiviral coatings, which are also eventually antibacterial. As you know, bacteria are single-celled, free-living organisms, whereas viruses are parasitic microbes. Most of bacteria are harmless except a few like E. coli, which creates stomach upset, like sulfur bacteria, which gives false smell to water, whereas viruses are deadly harmful and cause diseases to human beings. There are two types of viruses, enveloped and non-enveloped. Please see this slide. So enveloped viruses, they cause diseases like polio, hepatitis, and the coronavirus, which is creating havoc in the world today, is an enveloped virus. There are 7 different types of coronaviruses identified so far in the world. You have 229E, NL63, OC43, HKU1, MERS-CoV, SARS-CoV, and SARS-CoV-2. SARS-CoV-2, the virus we are facing now, was first detected in Wuhan, which spread to all over the world. There are a few antimicrobial agents currently available which can eliminate these viruses within a few hours of contact. Silver is a known antimicrobial agent we know for years, even for 5,000 years. Please see this slide. So silver in an ionic form is used as antimicrobial agent. It is quite safe for human beings. It is non-migrating and no leaching of silver is reported yet so far, and is very highly effective against a broad spectrum of bacteria and viruses. But silver alone cannot give 100% antiviral efficacy. You need a combination of few other antimicrobial additives. So there are inorganic and organic antimicrobial agents. Nano silver or copper, zinc, they are all inorganic antimicrobial agents. Whereas OBPA, triclosan, these are all organic antimicrobial agents. Inorganic is slow, but organic is fast. Inorganic may not decompose during heating, and organic may decompose at higher temperature. So we need a combination of inorganic and organic antimicrobial agents. CP, the pioneers and market leaders of industrial flooring since 1976, has now developed antiviral coatings which play a major role in combating bacteria, microbes, and viruses to safeguard the people against fatal infections. Here in CP, we have used a synergistic combination of organic and inorganic antimicrobials, which confer better antiviral efficacy. They protect against contamination and transmission of enveloped and non-enveloped viruses and bacteria that use floors and walls as hosting surfaces. So these are the brand names of some antimicrobial use in the world: Polygiene, Tricolson, Ultrafresh, Silpure, Cycrobial, Gem Shield, and their chemicals are also there. And in CP, we are using a combination of organic and inorganic. And this is the latest technology. CP hygienic floorings are engineered to excel in performance and offer long-term protection for patient rooms, operation theaters, clean rooms, laboratories, sterile rooms, and they eliminate cracks and crevices that harbor dirt and dust, making the floors antimicrobial and easy to clean and decontaminate. They provide a seamless abrasion resistant surface which resists the growth of bacteria and viruses. We offer epoxy antimicrobial floorings, EPU antimicrobial floorings, PU concrete antimicrobial floorings. They are found applications in hospitals, health centers, pharma, and F&B. And we also offer hygienic wall coatings. And our wall coatings are based on waterborne polyurethane. They are resistant to sanitizers and fumigation chemicals, whereas the conventional acrylic-based wall coatings cannot stand up to the chemicals in the sanitizers like alcohol, isopropyl alcohol, sodium hypochlorite. We offer our PU-based antimicrobial coatings, both one component and two component. We also have developed an antiviral clear coating, Aqua AM. Aqua AM is an antimicrobial clear coating based on waterborne polyurethane, which is engineered to provide exceptional properties and use as antiviral coating on all commonly shared surfaces. Aqua M confers antiviral and antibacterial effects to the applied substrates and protect against replication of viruses and bacteria. Aqua-M can be applied virtually on any substrate which is found in high use surfaces like glass panels, steel, plastic, painted surface, walls. These are the surfaces we encounter in a hospital or in common facilities. Aqua-M is also used as maintenance coating to keep the all contact surfaces free of infection of viruses, bacteria, and microbes. We have tested our Aqua-M for antiviral efficacy and found to be 99.8% resistant to viruses. Please see this slide. So you can see that the last column 99.8% against viruses. Similarly, we also got it tested for antibacterial activities. So we tested that in a Bangalore lab and we found that it has a resistance up to 99.99%, which means that Aqua M is antibacterial as well as antiviral. To conclude this session, we all know that we are now being surrounded with infective dangers and the need for hygienic coatings gain lot of significance today as epidemics break out at every decade, disrupting our normal lives. COVID-19 has pushed the hygienic coatings into limelight today. Thank you. Thank you very much.
Good morning. My name is P. Arjunan. I'm Vice President taking care of research and development for MEK Laticrete, the company based in Hyderabad, India. Today I'm going to talk about the advanced tile and stone installation systems. So what is the current trends for the fixing the tiles? What are the construction practices? Of course, the substrates are changing. It's no longer just a cement screed or a concrete floor. Similarly, the tiles are also changing. No longer we have a small format. There are a lot of variants, different varieties, designs, and stones are coming. Same with the stones. And as we talk about changes in tiles and substrate, applications also varied and diverse. It's no longer just fixing the tile over a cement mortar bed. And construction practices are, of course, is changing. We go with just no longer brick and mortar, but also you go with the walls like a Maiwan or floors like a very dense concrete floors. And it goes with the architectural designs. Very complex designs are there and no longer very simple. And also a lot of focus on environment and any buildings that is constructed, there is a lot of focus how it will make it more sustainable and user friendly. And to support this, the changes in codes, building codes also there. So when you keep all this in mind, then also when we talk about flooring or tiling, and that also has to go along with the changes what we are talking about. And if you see 40 or 50 years back, you would have seen these small tiles, very small, 50 by 50 or 100 by 100. And basically most of them ceramic tiles has a high water absorption and very, very less amount of mosaic tiles or a vitrified tiles, which has a very low water absorption. But nowadays we don't see this kind of tiles. Why? Because the tiles are coming in different sizes, different formats, different designs, and with a different water absorption. If you look at here, the ceramic tiles is a 15% water absorption. Whereas if you go to in a porcelain or vitrified tile, it's most commonly used nowadays is only less than 0.5%. And even less with the metal tiles that's also fixed on the floors or on the commercial areas or glass tiles for aesthetics. They have very no water absorption at all. Similarly, if we talk about natural stones, is another huge flooring or tiling category in India. Almost 50% of our construction or flooring is fixed with stones or marbles. And as you see from here, we have very varied water absorption. Go from sand type sandstones to travertine or granite, and you can see the variations in the water absorption. Why this is important? Because this really critical when we are selecting the right tile fixing materials, because the bonding and durability is highly dependent on the porosity of the stone or tiles. And also, as I said, nowadays we no longer see the small format tiles. We go with very large format tiles. They are very delicate. It has to be handled carefully, as I start with. And since they are all large format and to cover a proper uniform bed thickness, you need a thicker adhesive bed. Otherwise, you will not get the full coverage. And also, as you go with the thick bed, then long workability, then it's also going to go with a high water absorption. So that we have to keep in mind. Then the moment you talk about high water absorption, there is a possibility of warpage. And to avoid that, make sure that we have a high thickness adhesive that doesn't give away a lot of water. And if you allow with the thickness and water, then shrinkage problem always there. The moment shrinkage means then tiles start taking the stress and cracking, and that especially comes with the unmodified adhesives or the cement and sand slurry. And also, when you go to the large format, leakage is a very common problem. That means you will see undulations. When your floor is done, you can see that ups and downs on the grout joints. So other categories, engineered stone. It almost looks like a natural stone, but it's a factory made with resins, epoxy resins, and other additives to make it look like a more normal natural stone. But it has its own matrix, and that's a very moisture sensitive. And the moment you fix with any normal sand system, the moisture get into the stone, then they start warping and they start bending. Then you lose all the bonding and all the aesthetics and the money you spend on this kind of installations. So it's very careful what kind of system you want to select for installing certain categories. Even as you see in here, is a metal frame. They want fixed tile over this, almost each of them 2 by 3 feet large format tiles. And obviously, when you want to fix the tiles on these metal frames, you should have a really good adhesive material so that its bonding is very high. And the places like this looks like an airport where the vibrations and movements are huge. Then obviously you need a very good binding material. And this is how it looks like. Okay, once it is done, you can see that on the frames it is fixed. In other areas it's like a translucent. Okay, you can see that when the light is there, you can see from other side up. There is also another type of installation. It is fixing the marbles or stones on the ceilings. It's more for aesthetics, and a lot of places people are preferring this kind of good-looking installation. But again, it's a challenge because you are fixing on the ceiling, and like what we saw on the previous slide, it should be like a metal frame and over which you are fixing this. Then the material you are putting really should be really high strength material, high adhesion material, so that this whatever you are fixing on the ceiling is not falling down. And when you go with the facades, then there are a lot of designs that goes with that. Then that should be keep in mind for us when we select the right tile adhesive or material to fix the stone or tiles. We have to make sure that what type of substrate, okay, whether it is a highly absorbing substrate or no absorption, and what is the substrate aging, okay, whether it's old construction, then you may see a lot of cracks, and make sure that cracks are filled in so that you get a better adhesion and a tile durability. And what kind of tile or stone you want to do it, okay, you want to do it very highly porous or highly vitrified dense tiles or stone. Then what is the size of tile and stone, that's again matters. And area of installation, whether it is it's a highly rainy area or a dry weather or hot weather or humid weather, then accordingly you have to select the right adhesive or setting materials. Same way, height and installation is very critical, because when you are fixing a tile something 40-50 feet high, then you make sure that the gravity is not pulling down the tile or stone, so they have a right fixing material. And also at what season you are installing these tiles or stones, because that again matters. Okay, if it's a very hot weather, then you may not have high workability, so you have to make sure that you have a right material, long working material when you're doing in a dry hot weather. Or if it's a rainy season, again you have to make sure that the material is intact and it is not having problem with the setting during the rainy season. And is there any designs or architectural features that you have to take in mind? And above all, okay, when you go with this kind of situations, it's always expensive. Then do you have a right budget? Because if you don't have a budget, then you're cutting corners, then all of this will again fail in this installation systems. And also it's very critical to understand the movements in the buildings. Okay, there are all the constructions is done with the cement concrete, and concrete has a tendency to change as per the conditions, the thermal or climatic conditions. And also live and dead loads matters, and wind loads. Okay, what is a wind? Is a heavy wind that building can withstand, and whether it's going to impact on your tile installation, then what kind of tile and setting material you need to select. Similarly, seismic loads, where the areas where it's highly prone to earthquakes, then you have to make sure that you have a right setting materials. And countries like India, thermal expansion and contraction is a very common thing, and we have to make sure when you are installing tiles or stones on the exterior, then you have a good material that has a high flexibility, highly taking care of this thermal expansion and contraction day in, day out. And also, what are the shrinkage or creep for the buildings? Okay, if it's going to shrink forever, then I think it's going to impact your tile installation as well. And also, as you can see, it's a luxurious train. It's more for a tourism, and there is a special requirement to install tiles in the train, basically in the bathrooms. Again, it's a very challenging installation because you have to fix the tile on the metals, and also there's a lot of vibrations and movements. So then make sure that the tiles fixed is really strong, the material that's holding it, and also has a good flexibility. So as we talked about different trends, but still many places we still follow the traditional system of fixing the tile and stone with a cement slurry. So what is a traditional system? If you go to any construction site right now, you will see this when the building is ready for flooring. Then you will see that this is the situation where 3 to 4 inch offset floor is ready for tiling. Why this 3 or 4 inch? Because they want to leave this for conduits, pipes, and other systems. Then we have to fill this to have the level up to the door. So we have to fill with the sand. Okay, good amount of sand to taken into high-rise buildings. Then with a little amount of cement mixed with this, they spread it. They make a very loose bed of sand and cement bed. Okay, they call it as a thick bed, and over which once leveling is done, the mason sprinkles little amount of cement, then put a cement slurry over it, then fix a tile over it. And again, it matters what kind of tile, what kind of format you're using. Okay, if you're using a very highly absorbing tiles, then the cement slurry may be good enough to hold the tiles, good bonding. But if you're going to use a very kind of a low absorption or vitrified tile or stone, then it will not bond at all. Again, all the here you can see in the pictorial what happens when you put the cement slurry to the cement sand bed. So this is a traditional screed, basically damp sand with a little cement. They build up, the mason build up this maybe 2 to 3 inch, 70 to 75 mm thickness. Then over which he sprinkles a cement slurry. This is basically nothing but normal ordinary Portland cement mixed with a good amount of water to just have a good workability. And very thin layer he just pour over this cement bed or sand bed. Then again, these are all conditions, open conditions. When the construction is happening in the high-rise buildings, still the LC is not running. It's open, hot weather conditions, and wind also factor. Then the moment you put the slurry, you can see that the cement water is going to the cement bed, a sand bed. And again, the hot weather condition, all the evaporation is happening. Then the moment you fill the fix a tile over it, and you can see that all the water is sucked into the sand bed. Then there is no uniform tile coverage, adhesive coverage on the tiles. Okay, you can see that one area good amount of coverage, other area there is no coverage. So this leads to hollow sound. And when you put a small amount of stress, something like airport places where you walk, then the tiles start cracking. The moment tiles start cracking, you see this kind of situation. This is very, very common when you go with the traditional tiling systems. And that is because the cement is not there or a good amount of adhesion is not there. Now, all the water is taken by this sand cement bed. There is no water available for the cement curing. Then obviously coverage is very, very poor. Then it's a hollow sound. The moment you give a little force, the tiles will start cracking. So what is the alternate? That's what we call about modern adhesive technology. This is actually basically it's a factory made engineered cement, and it comes with a lot of additives, so that based on the nature of the application, and controlled cement and controlled sand gradation with a good quality additives. It comes in an airtight bag, so that means you can carry it anywhere, keep it for a longer time. And at the time of application, you take it and add just water, nothing else. Then mix it thoroughly in a bucket with a stirrer mixer. Then that's what you get. It's a good consistency, flowable material, uniform. There is no lumps, there is no water puddle, or there is no thickness. Then you can spread it very thin with a controlled groove thickness. So you don't need more material. You take a very small amount, 3 to 4 mm material, and spread it. Then you fix a tile. The moment you fix a tile, you can see that it's completely uniform and it's sticking to both tiles as well as the substrate. And again, going to pictorial, to repeat this, it's a floor bed, concrete, let us say RCC. Then over which we have a screed. That is again, it's a factory made screed. It is not just a sand cement that what we see in the other picture. So this is again allowed to cure for 7 days. So that means it's a very solid, uniform screed material you have over it. Then over which you are putting your tile adhesive, which we talked about. So spread it very thin layer. Then you put your tile and grout it with a good grouting material. Then once you flip it, you can see that uniform coverage. There is no gap. There is no one area more material, one area no material. It's very uniform and adhesion both tile as well as your concrete floor. And again, it's very, very important. Once you're done with the tile adhesive, then you go and fill the joints with a good material. Again, based on your application, you can go with the cementitious grouts. That's also factory made. But if your area is really highly traffic or it's a very special areas like a high moisture, then we always recommend go with epoxy grouts. That's also, it's a highly engineered material, factory made, it's highly durable, and it takes care of all the issues that comes with the normal cement paste or other cementitious style grouts. So once you've done this, I think your installation is completely done in a good manner. So what are the areas that we recommend for this epoxy adhesives? Mainly kitchen and bathrooms. Why so? Because there you use a lot of moisture and a lot of chemicals for cleaning, a lot of food items, and similarly restaurants, very similar situation. Shopping malls and food courts where you can have a similar situations, and high traffic areas like airport where you have a huge foot traffic with highly abusive traffic zones. Then you need a really durable grouts as well as adhesives. And swimming pool, the same situation, high moisture, harsh chemicals in it, so that you have a good grout in it, so that it is durable. And even in residential commercial toilets, the same way like bathrooms, moisture and chemicals, it's an area. And automotive workshops, there you can get a lot of oil stains and heavy areas, heavy workplaces. So make sure hospitals, you need a really clean areas. There is no dust, there is no other things, no moisture or fungus. So you really need a material that is highly durable and it's healthy materials. So these are the areas we recommend epoxy grouts and good adhesives. And what are the benefits of this material? Certainly it has a high superior stain and chemical resistance to cement grouts, and it eliminates all the cracks. There is no crack at all. Once it's done, then it's highly durable, no powdering, no shading, and color is very, very consistent. And whatever the aesthetics you want, it's maintained, and it's very, very easy to apply as you see in the picture. And also very easy to clean, and you can clean with the cold water, no need for hot water, any other detergents or any special chemicals. It's certainly user friendly and doesn't emit any harmful vapors. It's low VOC and no harsh odors. And more important, very, very important, it does not allow any growth of bacteria, fungi or moss, because all the water areas I talked about, especially wet areas, swimming pools, kitchens, restaurants and toilets, and also hospitals. It is very easy to maintain. You don't need to have very harsh chemicals to clean this every day, like what you do with the cement grouts. And the moment you do that, the cement grouts started deteriorating, then you have the hollow and water going into. And these grouts are again all follow the international standards. So there is no problem with the quality or guarantee of this warranty of these materials. So as we talk about all the situations, the tiles are different, substrates are different, designs are different. And what are the critical parameters for the right installations? Well, considering the tiles and stones are very, very highly durable, high design, low water absorption, we always recommend go with the polymer modified adhesives for the better bonding and better durability. And we also recommend epoxy based tile grouts for again the reasons we talked about just now. And it's very, very important that when you go with as I said, we are using a large format tiles, and it's very important that we backbutter the tiles so that the coverage is very uniform. And once done, then certainly use a rubber mallet to beat to get a uniform coverage, so that the tiles is keyed in with adhesive to the substrate in a uniform manner. There is no hollow sound, there is no open areas. And wherever you need, suppose you are using a large format tiles, then it's highly recommended to go with a high thickness adhesive bed. They're all designed to withstand all the shrinkage, and any kind of issues comes with the high thickness. Water shrinkage is very, very less. So again, 15 to 18 mm is minimum thickness we recommend for the large format tiles. And once done, make sure you periodically check the tiles for proper adhesion immediately, so that if any area it is have a hollow sound, then take it again, reapply and refix the tiles. And make sure when you are fixing the substrate movements and conditions, very, very important. Accordingly, select the right tile adhesives. And humidity conditions also very important. That helps on the curing. And it's very important that suppose you have very high strength adhesive material, your substrate is very weak, something like a plaster or something like a paint or something like your hollow blocks, then what happens? The substrate will cave in, because the high strength material will have a good strength adhesion to both substrate as well as the tile, but substrate can break, then the whole installation may come down. And that is very critical also to understand the vibration and shocks on the buildings. And the same way thermal variations and air conditioning systems, water coming in, going in, and temperature variations. All these parameters are very, very critical. So again, we talked about the traditional systems. We talked about the variations in the tiling trends, and we talked about the right adhesive materials. But again, it's very, very important we have the right standards, because everybody, when we sell the material, they follow the standards and they supply the material to meet these critical parameters. And recently in India, we came up with adhesive code IS 15477 2019. It was there previously, but only we modified, we upgraded to international standards. And this standard has come with several types, type 1, 2, 3, 4, 5. Again, you can see based on the types, there is a applications parameters also changes, where you want to put what kind of adhesive you want to select. Again, conditions, okay, the porosity of the tile, format of the, what's the size of the tiles, what's the substrate, what is the flexibility condition, and what other parameters we needed. These are all as a matrix is put in place. So somebody want to fix a tile on the external walls, then the format of the tile is more than 600 by 600. Then we certainly recommend that they go with the system type 3 that comes with the S2. S2 means it's a highly flexible. That's a transverse deformation. That means whatever changes happening on the wall, either it is a movement or it's a rain or it's a moisture or it's a hot weather or cold weather. So these adhesives are maintained or designed to withstand all these variations. That means they hold the tile in place, and any movements, contraction or expansion, it goes along with that. So that way it is not transmitting that stress to the tile surface or to the adhesives. So that way it's highly durable. So similarly, somebody want slip resistance, then look for the T in their classification, so that they select the right tile adhesives for the right application. It's really a good guide for anybody they want to see what is the application requirements for their application. Similarly, if it's a drywall adhesive, we recommend type 4. If it is an area where you want to fix metals or bond metals, then we recommend that epoxy or resin-based adhesives. And similarly, EN, of course, the Indian standards is also a combination of EN and American standards. They have a classifications. C1 is a very basic, unmodified adhesives, and T comes with a slip resistance. S1 means it's a more of highly deformable or flexible. S2 even more than that. And C2 is a highly modified. And again, when you have mosaic or highly vitrified or low water absorption tiles, we recommend go with the C2. And again, based on your application requirements, you can select any one of them. Suppose you want to fix a tile on the exterior on the large format, the lot of movements, then we recommend go to C2, extended working time and non-slip and highly deformable S2. So that's how the standards are available, and based on that, and you can certainly demand from the manufacturers, okay, I need this, and they can provide the material that meets all these conditions. Similarly, American standards, that's also prevalent in India. They come with the different categories. 118.1 is the basic mortar, it's a C1 type, where it is not modified. And if you go 18.4, 11, 15, they're all highly modified based on the requirements. And also they have a standard for 118.3 epoxy adhesive or the grout that we talked about. Okay, so then again, when you buy this material, and make sure these materials are meeting these standards or exceeding these standards. So to summarize, as I said, it's no longer 50 by 50 mm mosaics or 100 by 100 ceramic tiles. The systems are changing, and nowadays you don't get less than, not less than probably 600 by 600 or more than that. And again, when no longer that one solution that you take a sand, cement and fix everything, it is not possible. It's not going to give you a right material, right productivity, and a lot of issues comes with that. As I said, fixing everything with cement, sand, mortar will lead to short-term and disastrous results. So customer needs are different. So as a tile, stone fixing technology and the solutions. And that's where we are companies like MK Laticrete and other international companies. They are aware of these needs, and they spend a lot of amount of research and development activities to understand all the critical parameters, all the conditions They simulate in their laboratories. So what can go wrong and what is the right solution for each challenges. And also they make sure that when they offer these highly modified systems, they train the applicators and the customers. Okay, what is the right material, right application, right tools, so that when we do the application of tile or stone insulation, then we get the right application, right material, and right system for the money. So the modern tile fixing materials offer the tile adhesives are formulated based on the application on tile, as I said in the standards. They are factory made, guaranteed quality, uniform quality, consistency, and meeting international standards. Our materials are in India can meet any international standards. That's how we supply material. And they're all easy to use, user friendly. Anybody can buy this material, read the instruction on the back, and they can go and do the installation themselves. And also it's a faster application. It's quicker because no curing required, and you save a lot of time and labor and water and other cost savings. And when you do in the right way with the right material, no more failures, and hence no maintenance problems. So it saves a lot of money on the front too. And also nowadays it's very critical, and it's a very highly visible that everybody wants green technology, sustainable buildings. And as a manufacturer, we also make sure that we are catering those industries with the materials with low VOC or doesn't emit any harsh chemicals, or also use the industrial byproducts, so that we get the least points. So these are the advantages when you go with the traditional system. And again, you get a guaranteed performance and value for the money, and peace of mind as well. So to conclude, I think we have to understand what the application, what the requirement, and select the right material, and I think you will get a better results. Thank you very much.
Good morning, professionals. My name is Samir Sullakar. I am from the construction chemical industry. I thank CIDC for this excellent initiative for the revival of economy from this hardships and the hard times that our economy is going through at the moment. I also thank CIDC for giving Construction Chemical Manufacturers Association an opportunity to use this platform to put forward the new technologies which are more relevant during and after these times. I shall be talking to you on stopping the leakages by injections, which is one of the technologies which can help which can be helped during the construction as well as after the construction. Basically, I am a civil and a structural engineer by profession. I have spent about 40 years in this line of construction chemicals in India, Europe, and at other places. And this is my line of specialization. And I feel construction chemicals is a good line or a good field in which many new engineers can include themselves and even become entrepreneurs because the entry barriers are very low. As far as underground leakages are concerned, they are unstoppable during construction as well as after construction. We are talking about the concrete. In concrete, we'll always find the cracks and the capillaries. There are cracks. These cracks are the avenues for carrying the corrosion controlling constituents to concrete. So they have to be sealed from the point of structural as well as from the point of durability. These are the photos after repairs. Though we conduct repairs to enhance the durability, still in reality, the mortars that we are using are not shrinkage free. So they create these lines, once again, which are the avenues for entry of corrosion ingredients, as well as while repairing, they will not stop the process of corrosion. There are cavities in concrete, which is also important to be filled. It's a different type of cracks in concrete. You are aware of it. There are longitudinal cracks. There are cracks by different damages by mechanical means. There are surface cracks. At the end of the day, we have to take care of all these cracks. Also, I would like to say that it is not adequate to stop the cracks and put the injection material inside the concrete alone, because the source of water is behind the concrete, and that is the soil concrete interaction. We have to also take steps to stop that leakages or to stop that source of water to a reasonable extent, so that we can keep that source of water far away from the concrete to let the water inside. And injection technology gives you a chance to go behind the structures, to go into the soils and put a stoppage to the water permanently as well as temporarily during the construction and permanently during the life of the structure. Third important point is the joints. Joints are provided by design as well as joints are there by virtue of the construction problems. And these joints become avenues from where the water can leak. And however, we have taken all the precautions. It bypasses, the systems are bypassed, and these cracks, the joints are open, and water also comes from the joints. So the injection technology also provides for recreation of these joints. So main applications in the geotechnical engineering of the injections are in sealing, consolidation, and filling. So this technology comes handy during construction and after construction. Fortunately, there is a code EN 1504 which fully covers this whole gambit of repairs and rehabilitation, and also it covers the materials for injections. Before 10 or 15 years, whenever someone said about injections, we always thought it is an epoxy injection. We used to use epoxy injections a lot at that time to structurally regain the strength of the concrete wherever there are cracks, structural cracks. But epoxy has its limitations when it comes into contact with water. So this limitations is also filled by several other materials available. At the moment, whenever you start talking to people about injection, the first thing they start talking, oh, you mean PU, you mean PU foams. Please note, PU and PU foams is just the beginning of injections. These are purely temporary methods to stop the water, to enable you to seal the crack permanently. So this is not the end of it. There are different materials available, and these are to be classified. A good geologist and a good civil engineer, with the help of the existing codes of practice, he has to make a decision whether the cracks you require a ductile filling, or you require a force transmitting. Force transmitting means where there are structural cracks, where you used to use only epoxies, and due to the limitations of epoxies, in the conditions where there is water in the concrete today, there are structural polyurethanes which can be injected, which are more flexible compared to epoxies. So this can be also used by repairing the girders of the bridges where there is a vibrational loads. And finally, the swelling or the just for the filling, you can also use the foamed materials, which are either gels or silicate foams or polyurethane foams. So a large gambit of materials are available, but these are to be selected depending upon very, very few important things, which is the crack width, because crack width will determine the viscosity. Crack depth will also determine the viscosity, how deep you want the material to penetrate. It will totally depend upon whether the crack is dry or whether it is damp or whether water is coming out of it. If the water is coming out of the crack, you have to really stop that water incoming by putting a pressure with your machines to push back that water and the injection resin to reach the place where it is designed to reach. The crack movements, whether the cracks are moving on there or they are not moving. What is our target solution? We are doing the injections for structural stability, for load transfer, or only we are doing it for the preserving the durability for sealing. The applicability, the locations, the applications, whether we can take big machineries inside the project. So there are several different parameters connected to this. So this is a technology by itself. This is not only a technology of materials, it is also a technology which involves the machineries. And only by combination of good materials, good application technology, and with trained applicators, one can do successful injections. This is just to give you an idea. Viscosity, as I said, is very, very important. If you see water is having a viscosity of 1. And water can penetrate, water is what has already penetrated. So we have to have materials very close to the water penetration so that we can counteract with the effect. If we take gels are very close to water. They can penetrate and their viscosity is less than 10 MPa. When you talk about epoxy resins, you are having a very wide range of epoxy resins. So every epoxy resin is not for injection. From 17 to 100,000. This is very, very important. Silicate resins, they are also excellent from 90 to 330. So viscosity plays a very, very important role. The urethane resins, the polyurethane resins are having much lower viscosities in the cases so that you can really inject it inside deep cracks. You can reach you can use it as a filling, cavity filling injections. Just to give you an idea, honey is 10,000. Normally you cannot inject a material when it crosses 500 or reaches 700 viscosity. Other thing which is important is what offers the resistance to it is mostly the concrete. The surface tension. Surface tension is also important. Lower the surface tension, the more is the penetration. The less is the resistance required, the less is the pressure required to push these materials inside. While doing injections, it is not sufficient if those of you who have seen this injections of grouting many years back, you would be seeing some pipes are being tied, the pipes are bent, then they are tied with some bands. No, the connections has to be mechanical. There are different types of packers are available. Any length of packer, we can today inject as much as 75 or 100 meters or 200 meters below the ground with special lenses which can be connected to every meter. They are perforated. We can take the material until so many 75 or 100 meters below. We can make the material mix with each other at the point of injections. There can be specialized mixers. So pot life is not affected. So we have to use these connections. What is most important about the connection is the pressure that you put through machineries is not lost due to bad connections. You require also sophisticated machineries which are designed For example, when you have a very small pot life injection, which has to react with the react with each other within say a minute or less than a minute or even a few seconds, like 10 seconds, then you need a two component machineries. You cannot put both the materials in one component machinery. So you necessarily require two component machineries. Now these two component machineries, and when you use polyurethanes are sensitive to moisture. So these machineries should be so designed that there is no moisture which is penetrating. So polyurethanes is not the foams alone. Polyurethanes is foams is the basic thing, like one component foams, which are used for a very low pressure injection. So this is how it forms. The moment the material comes into contact with water, if you put a one component foam, it starts foaming. This can foam. Now this is very, very important thing what I'm saying. This can foam from 5% or from 3% up to 75%. So when you are purchasing the foams, it is very, very important is what is its expandability. The unit price is not per kilo price or per liter price of the foaming material, but it is the cavity that you are going to feel. It is also important the foam is hydrophilic, hydrophobic, whether it is open cells, whether it is closed cells, whether it is homogeneous, in how much time it starts foaming. This will be all dependent on the type of the projects that you have. So this is a basic foam, which is one component foam. One component foam is suitable for only temporary stopping of the material where the heads are not high, and where, because the second component, it's reactivity with water, which you cannot control. If the water is cold, it doesn't expand. You cannot control its setting times, and it has got a limited applications. If in case of structures like tunnels, if you see, the water will be gushing. Now with this type of water gushing, which is more than 6 bars, you can imagine yourself, if you start injecting this with cement or cementitious materials or even one component foams, the pressure of the water which is coming is a 6 bars pressure. You will not be able to stop with one component foam, even temporarily. Let us not talk about the permanent stopping, but even temporarily. So primarily, you will have to go in for two component injections, because two component injections have got controlled reactions. They are little bit hard compared to one component. The foaming capacity is less. Maybe the foaming capacity is up to 14 or 15. So they can really stop this water when you use real proper machineries to push this materials inside. So this is how from one component material you become a two component material. Then there are flexible materials, ductile filling materials. When you are talking in terms of pushing these materials in the cracks, in concrete, in podiums, and in other structures where flexibility is required, polyurethanes are very, very, very flexible. You can inject them. They are not sensitive to moisture. In cases like this, which you will normally see in basements, in underground, in parkings, you can see the water coming inside. This is the method of injection. You have to drill the holes at 45 degrees angle. You have to put the mechanical packers inside it, fix those packers so that the material reaches the center of the crack, and then start injecting the material with proper machinery, with proper connections. Here you can use the ductile filling material. These are two component polyurethanes, but these are having also limited structural capacity. Their aim is to seal these cracks. Their aim is not to increase the strength of the concrete, or this is not force transmitting injections. But these are also important in injections for podiums, for parking places. And then comes the most important, there are two component structural polyurethanes. Structural polyurethanes develop a strength of 70 to 80 Newton per mm square. So you can replace them with epoxy injections, even in cases of dry cracks, so that you don't have to mix with too many materials. They can be used underwater. There is no problem of hardening. They are not sensitive to moisture. Their foaming can be controlled from 1 to 15. They have a very high bond strength, very high shear strength. And this is very, very important for either for soil consolidation or force transmitting cracks. And these are the materials. So polyurethanes alone, foaming polyurethanes is not the end of the story. It is just the beginning of story. So even if you do the temporary stoppage of water, if you do the temporary stoppage of water by one component foams, for permanent stoppage of water, you will have to go for two component structural injections. It's just demonstrating it to you how it works, because this structural injection can be used in the existing structures, as well as they come a lot handy when you are building things like tunnels. In tunnels where your geological examination is already shown that maybe 70 meters ahead, you are already having a fractured rock from where water is coming. Now you cannot stop your TBMs going. So this comes very handy.
Hello and good
You
morning.
also please, that means
I'm
you just
Himanshu
inject
Kapadia,
it. If you see that
and
it is in gravels are been put, the water is coming from top, and on the right hand side it is second and fraction of seconds. So you start injecting a structural polyurethane. It's only 7 seconds. First thing, the speed of reaction is very, very important. In 7 seconds, in fractured rock, you're putting the materials. In about 17 to 20 seconds, that much, or 20 seconds or 30 seconds is required so that the material can spread all around. Because you cannot just make it set within 1 second or 2 seconds, because the material has to also spread all around. Then it has got a foaming capacity. When it comes into contact with water, its reaction starts within about 30 to 40 seconds. The reaction has slowly started. And it is a structural permanent solution. If you see now, the water has stopped going inside and the water is raising. If you see from the bottom, the stream of water is getting reduced. It has expanded, not very much, but to the reasonable extent so that it is spread all around. The water from top is flowing out. The water which is coming out with gushes, it is now slowly stopping. And within a matter of 1 minute, the total process is over. This can be similarly used in our basements. We are having a lot of problems in our basement. The water comes inside and you cannot stop it by foam. If you stop it by foam, tomorrow, once the foam is thrown out, the foam is not durable. These materials are tested for durability of 100 years. There are long-term tests been done in field of about 20 years, and then by extrapolating, these materials are very suitable and remain almost permanently, which is very, very important. Foam is not stable. Foam does not have a capacity to bond to your concrete. Foam does not have the water pressure bearing capacity. So these different polyurethanes are very, very handy when you try to stop water during construction. For example, this is the type of the water. You can try to put any foam inside, which is expands 50 times or 40 times. It cannot stop the water. Because to stop this type of water coming under such a pressure of 6 bars or 10 bars, you really need polyurethanes which are structural, which can harden totally underwater within a period of 1 to 2 minutes. So totally your construction can go unabated, as well as it forms a permanent seal. It's a permanent solution. If you see the water is going on reducing in a matter of just minutes. So this is the real live stopping of water. So within about 1 or 2 minutes, the flow of water is reduced. And these are the only means of providing permanent solution during construction as well as after construction. Still more versatile resins are the two components silicate resins. There are also, polyurethane is not the end of the story. There are silicate resins. This is organo-mineral silicate resins. Silicate resins, there are also foaming silicate resins and non-foaming silicate resins. Silicate resins bond very well under wet conditions. Silicate resins, they also foam structurally. Say 1:3, they can be used for the lifting of the structures. So they can go very nicely inside the soil and do the stabilization. They are structural. They can be also used for example, for the same purpose that we use the polyurethane injections. If there is a very fractured rock, we can once again, and there is no water, there can be a fractured rock with water where you need polyurethanes, because polyurethanes form only in presence of water. Whereas as far as silicates are concerned, silicates form on their own and they can glue. They can glue this fractured rock, especially during constructions. You see here, this is now already injected. This foam with restrained expansion also develops sufficient structural strength. So when the machine passes through, it offers enough resistance. You can see the very fast foaming. Even if there are some remnants of water, it will throw away. These are also available. These are mostly used on TBM machines, and this would be a good example to show a tunnel boring machine. When the tunnel boring machine is moving around, geotechnical surveys have already identified that X meters you are having. So you are already putting in the silicate foam. It cannot move, the shield cannot move. So the silicate foam is injected. This foam is not injecting 50 or 60 times. Within 45 seconds, this has got, they have maintained the foaming factor to 8 to 12. See, one thing you have to remember, you'll see some certificates which will tell you my foaming is 1:15 and my compressive strength is 15 Newton. This is not possible. Because on one foaming factors they give as a foaming factor, the tests are done with only 1:1 or 1:3 foaming factors. So you can't have both the things. As the foaming increases, the compressive strength decreases. Now these foams are also excellent for soil nailing. You have inside, you have the soil nailing, say about 15 or 20 meters. You got self-drilling anchors. It's a very, very versatile material. It doesn't expand. In this particular case, it is non-expanding. It will slightly expand so that it creates a bond. If there is a water inside the structure, you cannot use the epoxies for fixing your anchors bar. Whether it is self-drilling anchors for soil stabilization or it is even transfer of loads in your RCC repairs to be done to foundation below the water, there you have to go in for silicate technology. So you shall be seeing now how many materials and how many parameters a geotechnical engineer has to consider before just writing specifications, which I see in many dam specifications. He said repairs are to be done by 2-component polyurethanes. This does not say anything. The performance criteria should be given. What strength you require for repairs, what viscosity is required, in how much time, for example, this develops a pull-out load up to 20 tons within about 10 seconds, within about 10 minutes. Within about 10 minutes, your reaction is over. It is developing the full strength. And these are the resins that you have to consider as new generation resins, and a still more versatile development or still more versatile material are the acrylic gels. These acrylic gels, they are fantastic as far as the sealing is concerned. They have got adjustable pot life. You can adjust the pot life from 9 to 10 seconds up to 30 minutes, depending on the flow of water, depending upon the penetrability. They have got a very, very low, the lowest viscosity. they can penetrate to the finest possible pores. As good as it is, as good as water. Wherever water can reach, they can reach to. They're more important, which I will come on my last slide, which is very, very important. They should be approved for use in groundwater. There have been major accidents, which I will show you. You can go on the net and find it out. Under the name of gels, some wrong poisonous materials are still being used. You have to be very, very careful. They should have a groundwater clearance certifications, especially coming from European countries. There is a CE marking, there is a groundwater certification. You should ask for certificates, and there are durability certifications. There is a durability certifications for gels, also for 120 years. A testing in the field for 20 years. Please note, every gel is not a gel. Some gels, they will just become gels. After some time, they will shrink. Once they shrink, the joint or whatever it is very vulnerable to the water entry. So they react very fast. You can see within, they are having up to, when it reaches say 100, the viscosity of 100 MPas, it is still pumpable. Then the reaction time, in about say 10 to 12 seconds, you can control it. Then it starts increasing in the gelation time, and it is gelled. Within about 20 minutes, it is a proper gel. I will show you one or two videos to show you the type of the gels. These gels are normal, as well as these gels are also can be fortified with acrylics to give it a characteristics which is so flexible, which you can convert it into a joint filling material. There are so many projects they are coming to us in this type of railway underpasses. The railway underpasses, they are normally made out of precast element having a depth of about 4 meters. They are 4 meters in the length, and the depth of about 60 centimeters. They are placed side by side. Sometimes the joints are filled by some boards. Sometimes they are filled with some other materials, but they fail, and the water starts coming inside the roads. The roads become unusable, and the gels are the only solution. Please note my words. I'm saying only solutions, only permanent solutions. Initially, you can put some foam inside to stop the water if it is coming in a very big conditions. But if you see these joints, sometimes there are water stops are provided in the two connecting things. Sometimes we put the styropor inside. Sometimes you pull the Cyrodex or dimple boards inside. But by some chances, these are breached. The water still passes. The joints become very vulnerable. There are suggestions from the people saying that you use only foam, no problem. It is stopped. Of course, it will be stopped for 2 months or 4 months or 6 months, because foam is not a permanent material. Some people say you put some other polyurethanes inside, rigid polyurethanes or flexible polyurethanes. No, this won't help either, because you have to create a joint sealing material. A joint sealing material should have adequate bonding on the sides. Joint sealing material should have enough elasticity for expansion and contraction, and it should become a seal. Joint sealing and joints, because this is very, very important. So any other method won't work. So over a period of time, when you use the gels, you inject. You can see it is such a simple process. It's a single step process. You make this simple one step process into 4-step process or 5-step process, or put some injections inside, put some foams inside. Okay, you can still put some foam inside to stop the water initially, but permanently what is important is a gel which will set inside. This material is also very, very important in precast joints. In precast joints of the segments, you have already gaskets put inside. However, due to the constructional problem, these gaskets are not 100% waterproof, and the water starts coming in through gaskets. But please remember, at the end of the day, they are joints. You can inject through the joints by needle injections. Also, you can inject it from 2 different sides. You don't have to puncture. Sometimes you can directly puncture the gaskets, go behind it if the water stop is less, water not stop. If the water entry is less, if water entry is more, You can do it through the packers, which are put at 45 degrees. They go behind your gaskets and then create the same thing what has been created. The same technique, you are going behind that physical barrier. Some physical barrier you should put. If they have not put a physical barrier, and if your width is 60 centimeter, you can put some Silodex board up to say 30 centimeters. So automatically you get a physical barrier. Go behind that 30 centimeter at 45 degrees angle. Inject a gel inside it. So a little bit of gel will come because there is not a sealing with the thermocol or Silodex board or dimple boards. Some material will go there. It is good for you. If you want more in sophisticated, if this comes in the factory floorings, you also have got a small portion kept above. You can feel a joint filler. You can seal that joint by polyurethane joint sealants or polysulfide joint sealants. So many joint sealants or polymer joint sealants if it is to be used. But this is the basic techniques. There's no other technique, and this cannot be a temporary thing. I wanted to show you, for your interest, the material. What material is going inside? It is not enough a rigid material like polyurethane, which I showed you, goes inside. This is just to show you what is the material that goes as a gel. This is a fortified gel. This is just a tire to show you. You see, this is the material. Two components. Simply we are powering to show you the type of the material. It gels within no time. Finished. The material is already started gelling. It has already gelled. It is a gel. It is a 3-component gel, A component, B component, an accelerator, and fortified polymer. You can see here within seconds, within 10 to 15 seconds. And this is the material that is to go inside the joints. If you tell me you put any other rigid polyurethane inside, you put a flexible polyurethane inside, within 10 minutes, it has developed adequate bonding strength, which is most important. Any material you are using to recreate the joints in the segments or to recreate the joints for the underpasses or any other joint from where the water comes. A joint is a joint. It is to be treated like a joint. The bonding should be there on the sides and it should have enough elasticity. You can see here within 10 minutes. That means any water that is coming, it reacts with water and it is totally elastic. What is more important is this material is tested with proper certifications, with proper certificates for a period of 20 years in the field. There are official test certificates are available for this because the durability. Once you try to put something in a metro project and the metro project is designed for 120 years. Any material that you put behind should have, and also when these are below, you can see it has been tested for 7 bars. That means if you take a foam, a 1-component foam, even if the pressure is 2 bars, it will throw the foam out. If you take another 2-component foam, maybe 4 bars, it throws out. These materials are to be essentially tested as per EN 2504 to 7 bars, but they remain live even up to 12 bars. That means 7 bars means 70 meters of the head. And the durability testing, these gels are liable to expand and contract inside when they are inside the mud or inside that in connection with water. They can be tested. Now this has been tested up to 14 years in field. How much it is expanded, because when there is less water, it shrinks. When there's more water, it expands. If you see the cycles over a period of 14 years, and this can be extrapolated. This can be extrapolated, and engineering estimation of a durability of this gel is 120 years as compared to your PU foam. Or a PU foam doesn't bond to concrete. A PU foam cannot go inside the joint. It can't bond on the sides of the joint. A PU foam cannot be so flexible as what I said. PU foam cannot be living for 120 years. So if you want to do some permanent solution, these are the permanent solutions are available to you. And more than that, what I said, this has been tested. These have been tested for pressure, and durability in field up to 12 bars. This I think there's a no-dig show going within simultaneously. There's a micro tunneling. Even if there is a water pressure line which is having a pressure of about 12 bars, and the joints are leaking because they can be also built. They are micro tunneling, but they're also built in the segmental way. The water can go inside, which is very dangerous. Drinking water can go outside. There's only one way to stop it as of now, using fortified gels. It is not one component polyurethane. It is not two component polyurethane. It is not one component or two component flexible polyurethanes. It is not a two component structural polyurethane, because we need here a flexibility. We need here a good bond. It should remain under pressure, and we also need the durability. So these are the solutions available now on a simple example. If there's a basement, this is a basement which is done in Bombay. This is a 6-level basement. A 6-level basement in BKC, where the water was coming with this strength. And we use the same technique. Since more water was coming in the beginning, we use the polyurethane foam, a one component polyurethane foam or a two component polyurethane foam, to stop more water coming inside. And that is a temporary solution. You need to use a foam. A foam is a temporary solution. A foam is not a permanent solution. We used also some physical means. You put some rods inside, you can put some lead inside, you can put, because the water has to be stopped, because injection has to work. And then we are injecting, of course, with the knowledge of the structure, we are injecting with the knowledge, the expertise, with the trained applicators. This is 6 floors below 16 meters basement in Mumbai. And this can be stopped, the water can be stopped permanently. What is more important is a permanent stoppage of water, not temporary. They have done several trials for several years. So many people have come and injected so many things. A cement was injected, a polyurethane was injected, a rigid polyurethane was injected. So many things was done. But here also, what we have to finally create, we have to create a sort of curtain walling, a curtain behind the basement. A curtain behind the basement, which can be even for the 7 bars or 70 meters. So it forms a membrane. That was our trained applicator standing there with machinery, well trained. This machinery is from Italy, 2-component machinery. It is beginning for injection. You require an expertise. We offer trainings. This is a beautiful opportunity for the new engineers to go in for their the internships, or become entrepreneurs. During this time, the jobs are less. We are injecting now behind the basement wall. We are not injecting in the concrete, we are injecting behind. So what we are doing, we are creating a positive waterproofing from a negative side. We are standing inside and creating a waterproofing layer outside. So our whole aim, it is not only stopping the cracks in the concrete from where the water is coming, but we are stopping the source of water. We are keeping that source of water away. And as I already discussed, there's a durability. A durability is guaranteed durability. It is not poisonous for any water, and the water is completely stopped permanently. I request you, please use these technologies. Please use your engineering knowledge. Please use your geotechnical knowledge. Please use your civil engineering knowledge. Please use your common sense, civil engineering common sense, I would say. And this, the final use of the injections is also to do repairs of the infrastructures. You must be seeing at many places there is sinking of the slabs there is sinking of the slabs. That means the slabs like runway slabs or the highways, they settle. Now when they settle, you have to really see that which material can penetrate. So this is a guideline. You can see you are having permeabilities from 100 to 10, from 10 raised to -7. So differing on, it depends on all different type of soils and are been put on one side. All the materials are put on one side. We can even go almost to the half the clay penetration capacity. Which material is to be used? This is a small handout or a guideline you can run. which material can be used when water is there, which material is to be used when there is no water, which can set in water, which can set without water, which can set in water or outside water. This is for purpose of injection in soil. The reason I'm telling is when you are doing, these are the strengths developed. If you see a cement suspensions, micro cement, that develops a very, very less than after 24 hours. The strength developed is not even 10 newtons. After 28 days, because you are putting so much of water into the cement suspension, it's only 15. If you use a good concrete, after 2 hours it starts setting. But before that 2 hours, if the water pressure is high, it can be thrown out. But if you use the silicate resins, you can see within 1 hour or within 2 hours, it can develop a strength of up to 50 newtons. It is very important to select the type of material. This is where it is settled. Now, please remember one thing. This is a pure common sense. When something is settled, it settles because the bearing capacity of the soil is not adequate enough to take the surface loads. Now, this is very important. So, when you are trying to lift up the slab, lifting alone is not enough. You have to first consolidate. Once again, this is engineering property. After consolidating, then you lift it and lift it properly. Then the problem will be solved. This happened to us in one of the quotations which we have given for a big project. They said the other person is doing lifting the slabs only at 20% of the cost. Well, lifting the slabs is not a big problem. The moment a lorry or the plane lands on it, since the underground soil is not consolidated, once again it will go down. Lastly, it can be used very effectively in dam structures, embankments. If there are streams going from upstream to downstream or the other way around, this water can be stopped by geologically, by georadars, knowing where are the streams. The surface can be stabilized by using acrylic gels wherever necessary. And this is most important things, I think. This is one thing which you can simply go on the website and you just put Halland Das Tunnel project, and you will find this is the accident which took place in about 1995 to 1997. The name of the company which was manufacturing, they put about 14 tons of gel inside to stop the water from this underground tunnel. Fortunately, there was no loss to human life. This gel was poisonous. This gel is an acrylamide gel. It is poisonous. So please be careful. Everything that gels is not the end of the story. You can see here, farmers near the construction site started complaining about the cattle becoming paralyzed. They killed about 370 animals to stop giving adulterated milk, adulterated by cows themselves by ingesting this. Human lives did not get affected. 29 wells were poisoned. People could not drink that water. And this is very important. So this is not sustainable. So please get your certification. Say only because a product costs 100 rupees less, and if it creates this type of havoc, one has to be very, very careful. This project stopped for about 7 years and was, I think, between 2009 and 2015, it restarted and now it is completed, but it created this havoc. So at the end of the day, what is important is people need a good training facilities, because you have to have trained applicators, which we can provide. People can be trained by foreign trainers, or people from India can be sent to foreign country for short-term training. Certification is very important. We need the help of CIDC to provide the certifications, because our own certifications are not that valid. If government can help us approve these trainings, those certificates will have a lot of validity. So many civil engineers who are new, they can go for internship for these injections. They can become entrepreneurs. They don't have to rely on someone to become, because they can buy one machine, they can get a training, and they can use it. Ultimately, once again, to repeat, this should be sustainable. Sustainability is the most important. Any technology that you bring to the country Please be careful. It is sustainable. It doesn't kill people. And polyurethane injections is not a polyurethane alone. Injection is a wide gamut of, it is an engineering field. You require a technical knowledge. The universities can start courses. The professors can learn more about it. They can have hands-on experience. So I thank once again CIDC, who is making attempts to revive the economy, and this type of materials will be needed because now we are going for more and more underground constructions like metros, hydroelectric projects. And please note, by use of engineering knowledge, by use of engineering materials, the problems can be solved, and the constructions as well as the completed constructions can live peacefully for more longer time. Sustainability and durability is the key. Thank you very much. Thanks for patient listening.
Greetings. I am Prasad from Bowling Divisions of Pidilite Industries Limited, and my co-presenter is Jose Ballester Ortiz, who is from Grupo Uma Spain and also goes by a smaller short name, which is easy to remember, Pepe. So from now onwards, we're just going to call him Pepe. We are going to be talking about EIFS, an energy efficient architectural facade solution. And at the outset, let me say that we are extremely grateful and appreciate the opportunity given to us to present this topic to the august audience of industry stalwarts and experts and industry participants. Thank you. Just to start with a brief background of Pidilite Group Uma Manufacturing Limited, it's a JV between Pidilite Industries Limited and Grupo Puma Spain. which is going to start, or in a limited way has started this operation in India already. And we are coming up with manufacturing facilities and state-of-the-art R&D facilities, support systems, foreign expertise to support the business in the segment of technical motors in India. To give a bit of background of Pidilite, Pidilite has been manufacturers of high quality products and is catering has been catering for many years to for to a small applicator who might be doing a very small plastering job with 10 or 15 bags of cement, to very very high end and complex projects like tunneling and metros and multi-story large developments. Uh, Also, we have state-of-the-art R&D facilities, in-house execution capabilities, which rests with our partners and with our JVs, Nina Patsep, CP, and we have the capability to service across all states. I believe that now we have even capability to service villages which are around having around 5,000 odd population, and also internationally we are having a sizable presence in Middle East and South Africa. Talking about our partners, Grupo Puma Spain, they are a market leader in Spain in the field of technical motors, and they have very high-end expertise in restoration of old architectural monuments, and they have more than 20 manufacturing facilities in Spain. They have a presence in many European countries, have manufacturing facilities in Algeria, Morocco, Costa Rica, Portugal, and France. Also, they are trying to make headways and are reasonably successful in Middle East, Latin America, and South Africa. I am going to be the agenda, or I am going to be talking about a bit about energy consumption patterns in India, energy efficiency initiatives, ECBC 2017 guidelines, and Pidilite solutions for ECBC compliance for both roof and walls. And the main agenda for today is a detailed presentation on EIFS, which will be done by Pepe. Energy consumption in India. Present energy consumption in India is 12 gigawatt hour per annum, which is expected to rise to 13.5 gigawatt hour by 2030, which roughly is about 12% more. Almost 65% of the energy generated in India is by thermal power plants, with obvious high production cost and more environmental damage by CO2 emissions. Major contributors for energy consumptions are industries at 42%, buildings 33%, agriculture 17%, and others 8%. Building sector contribution is 33% to the total and is expected to rise at 4% CAGR and reach 55% of total contribution by 2045. Industries 42%, buildings 33%, agriculture 17%, others 8%. In the commercial building segment, the large consumption is in the area of HVAC, which is 55%, lighting, which is 25%, internal load 15%, and others is 5%. Uh, Energy efficiency initiatives taken by government and private sector. Uh, as all of us know, the present government especially is focused on energy savings and on environment, and has made pronouncement and commitments nationally as well as internationally, and has taken a leadership positions for for CO2 emission reductions internationally. India has committed to reduce the emission intensity of the economy by 33% by 2030 from 2005 level. There are multiple initiatives, but what we just going to briefly talk about is ECBC. So for energy use optimization, Energy Conservation Building Code (ECBC) had been framed in 2007 and revised in 2017 by Bureau of Energy Efficiency, which basically makes it more stringent, has more focus on the infrastructure for the implementation of ECBC guidelines, and also certain standards and processes for monitoring the progress and implementation of the ECBC code. Hypothetically, if ECBC was implemented in 2007, savings would have been 4.3 billion electricity units and 30 million metric ton reduction of CO2 emissions. ECBC 2017, the primary objective is to provide minimum requirements for the energy efficient design and construction of buildings. The scope is for both the commercial building as well as residential building. Right now, it has been made mandatory for commercial buildings which have a connected load of 100 kilowatt or greater, or a contract demand of 120 kVA. Whereas for residential buildings, the ECBCR has been introduced, but has not been made mandatory, and but it is likely to become mandatory in the near future. There are three levels of compliance: ECBC Basic, ECBC Plus, and Super ECBC. ECBC Basic level compliance is been made mandatory, and ECBC Basic should give an energy saving of 25% to when compared to a typical building. ECBC Plus should give 35% energy saving when compared to a typical building, and Super ECBC should give 50%. Now there are two methods of achieving ECBC compliance. The first one is whole building performance method, and the second one is prescriptive method. In whole building performance method, basically it has been left to the project owner to decide on how to configure the projects and the various elements to achieve the basic compliance mandated by ECBC, and guarantee an energy saving of 25% minimum over a typical building, which has to be attested by energy simulation software approved by B. So here the prerogative and lies with the project owner to do what he finds more convenient and more feasible for them. Whereas in prescriptive method, there already exist standard and specifications for various elements of the buildings, which a project owner has to meet to comply to the ECBC basic standards. Say, for example, for the building envelope, for the roof as well as for the terrace, there are certain U values defined which a project owner has to meet to take the ECBC compliance. Now, as Pidilite, we prefer and recommend prescriptive method over whole building performance methods, because mainly we feel that this is much easier to comply with, because the values are already given. They are easy to achieve. They can be achieved by the simple process, by the materials which are already available in the markets. Also, because it is already specified, the absolute value are specified, then it is easy to implement it and measure how much value has been we have got. And especially this is very good way to achieve compliance in case of retrofit building, where the project owner doesn't actually have to make any changes to the structure of the building. They can just put it on the facade and on the roof and achieve the basic compliance. So by prescriptive method, depending on the area and what a zone the project falls into, has specified certain U values to for roofs as well as for walls, which are given here. So there are basically 5 climatic zones: composite, hot and dry, warm and humid, temperate, cold, and different type of buildings, and they are already prescribed. So I believe Karnataka is the only state where all 5 climatic zone could be found. Now, Pidilite offers solutions both for wall as well as for roof for meeting ECBC compliance. So for the roof, we have, we have a low energy consumption systems which we offer for the roof, which includes both the product as well as the execution. So basically, the project owner has a scope to take different type of material at different U values, different thickness, different waterproofing guarantees. We actually, probably we are the only company which offers 25 years waterproofing guarantee, and it is possible to meet and achieve much lower U values compared to the prescribed U values for roof by going for Pidilite LEC systems. As for walls, we offer EIFS in collaboration with our joint venture partners, Grupo Uma Spain, who have extensive experience in the product development, in the execution, and they have done projects, and we have lasting for more than 20 years, and with multiple facade options, beautiful architectural finishes. So we will be offering EIFS for the wall insulation. And to talk about EIFS in details, I invite my co-presenter and partner Pepe. And once again, thank you for giving us this opportunity. Pepe, please take over. Thank you.
Thank you, Prasad. As we have seen all this information, we have decided to develop a new thermal isolation system. We are going to see why we decided to make an EIFS. Which are the main advantages of EIFS systems? Okay, first of all, the main studies of energy saving of buildings says that most of the losses of energy in buildings comes from across the walls of the building. The 40% of losses of energy goes through the walls. That's why we decided to develop a thermal isolation system for walls. This kind of systems will not be an expense, but a profitable investment. In a short time of time, we will recover the amount we will spend in the installation of the system by the economy in heating and refrigeration energy. We will reduce thanks to the installation of the isolation system. As is a system installed outside the building, it has several advantages in renovation of existing buildings, because the installation of the system doesn't affect to the habitability of the building. So the use of the building, the normal use of the building, can continue meanwhile we are installing the system, the isolation system. And in addition, we are not losing any space inside the building. We keep all our space because all the components of the system are installed outside. Okay? As this system works as an envelope of the building, we are not only isolating the thermal, getting this thermal isolation of the building, but also we are protecting all the structure of the building, all the materials of the structure of the building, because we are protecting it from the weather agents, the wind, the rain, the change of temperature. All this doesn't arrive to the components of the building. So we are making the life of the building longer. All the components of the system and the system itself are waterproofing and are also permeable to water vapor, so they breathe the building. As there is an external isolation, we eliminate all the thermal bridges we have in non-isolated and even in buildings isolated inside, okay, because we have these thermal bridges in the slab of the building, and with our EIFS we don't have this kind of thermal isolation that can give us this kind of problems. So we avoid these problems of molds inside the building because of the thermal bridges and the difference of temperature between inside and outside of the building. And as if it's an outside installation system is installed in the facade of the building, we are not only getting this thermal isolation, but also we are renewing aesthetically the facade of the building. So we are improving the value of the building. Okay. So we have decided to do this EIFS system. We are going to see now the main characteristics and components of this Traditherm EIFS system. As a system, we are offering all the components to the market. Pidilite Grupo Puma not only has the mortar and the finish or the panels, but all the complements and all the necessary complements for the installation of the system. The installation is very simple. We place, first of all, the starter profile, fixing it directly to the wall. We will place the first line of panels over this profile, which marks the starting line of the system. We will fix the panels to the wall by using the special mortar, fixing all the panels to the wall. After that, we will improve this fixing of the panels by installing the Traditherm anchors. We will make a panel sanding to uniformize, to homogenize the absorption of the panels, to improve the adherence of the coat of mortar we are going to apply now. And we will cover all the anchors with mortar. And after that, we only have to apply the coat of Traditherm mortar. This is a more or less 5 millimeters coat with a mesh, reinforcement mesh inside the coat of mortar. That will give us all the mechanical resistance we need in the system. And we will finish with Mortenkrill Fondo primer and Mortenkrill acrylic mortar, which gives us the aesthetical finish in addition to waterproofing and protection of the facade. This is a 5 millimeters mortar, which gives us an aesthetic finish with a wide range of colors. So the first component, the main component, is the mortar. We have 3 kinds of mortar. First mortar is Traditherm standard, is the most commonly used mortar, and we use this mortar for fixing the panels to the wall and to cover these panels with a render of 5 millimeters more or less of this mortar. This mortar is a waterproofing mortar. It's a breathable mortar. It's permeable to water vapor, so it leaves the building breath, and is specially formulated to fix this kind of panels, isolation panels. So adherence is very, very good. This mortar, all the components of the system follows the European standards. So we check all the quality controls in order to follow all these standards. The second one is Traditerm projectable. It has the same characteristics of Traditerm standard, but in addition, we can make the application of this mortar by using a projection machine. So we make a faster application when we reduce the time of application of the system. For big buildings, is a good option if we have the machine. And the third one is Traditerm flexible. This is a flexible version of our mortar. It's a cement-free mortar. It's ready to use, and we recommend this mortar mainly for the flexible version of Traditerm system we are going to see later. Second component is the isolation panel that give us the isolation, thermal isolation of the system. We have three different isolation panels. The first one and most commonly used one is EPS panel. Is a high density EPS panel. We have it in different thicknesses depending on the level of isolation we are looking for, and is a good solution for thermal isolation because thermal conductivity of this material is between 0.036 and 0.038. So this brings us a very good level of thermal isolation. Second one is mineral wool panel. Thermal properties of this panel are very similar to EPS panels, but in addition, this panel has properties of resistance to fire. So it's commonly used in projects where we need this special protection because the size of the building or the use we are going to do with this building ask us to improve this fire protection. And the third one is the XPS panel. This kind of panel has some advantages comparing with the others because mechanical resistance are a little bit bigger because it's a more rigid panel, and isolation level is a little bit higher than EPS or mineral wool panels. Not so much, but a little bit more. But in opposite of this, since these are very rigid panels, we cannot use them if leveling of the substrate is perfect. It's not perfect. If we don't have a 100% leveled substrate wall, we cannot use this kind of panels because we can have tensions which develop crackings and problems in the future. The installation of these panels can only be made by the notched travel system and not by the core system because of the same. We need a perfect wall and continuous layer of adhesive. And the third component of the system is the finishing. We recommend as finished this acrylic mortar. We have different versions of acrylic mortar too. First of all is the primer. We use this primer, this Mortencryl Fondo, as a primer to homogenize the absorption of the system, of the substrate, of the mortar we have applied before. And as this is a colored primer with the same range of colors of the acrylic mortar, we reduce the amount of acrylic mortar we will need after to cover the surface. After the primer, we can use different kinds of acrylic mortar for finish. We have a standard Mortencryl standard, is the most commonly used one. Is an acrylic mortar, cement-free, is waterproofing and breathable as the other components of the system. We apply in 5 millimeters, and with this layer of 5 millimeters, we have the necessary waterproofing or rain of the building. There are a wide range of colors we are going to see, and it's easy to apply. 100% compatible with the Traditerm mortar. In the lower part of the building, where it's more attacked by people or traffic or so on, we can apply this second kind of mortar. Is Mortencryl Mosaico, with the same characteristics of waterproofing and breathability of Mortencryl, but with more mechanical strength than the normal Mortencryl. And the third kind of acrylic mortar is Mortencryl Flexible. This is a special formulation of acrylic mortar, especially recommended for the flexible version of Traditerm system, and has the same characteristics of Mortencryl or Mortencryl Mosaic in order of waterproofing and water vapor transpiration, but is also more flexible. So we will use in situation where this flexibility is necessary. This is the color range of Mortencryl, Mortencryl Flexible. We have a wide range of colors, and this is the range of colors of Mortencryl Mosaico. And in addition of all these main components of the system, we have all the complements necessary for the installation of the system. We have this Traditerm mesh. We have talked about this mesh. Is the mesh we place inside the layer of mortar to improve the mechanical resistance. The aluminum starter profile we use to start the system, place the first line of panels. Traditerm anchors to improve the fixing of the panels to the wall. The Traditerm guttering profile with mesh, and the Traditerm PVC corner reinforcements with mesh. This kind of profiles to protect all the corners of the building and to avoid several aesthetical problems of dust in the wall. Traditerm window finishing profile to use in the joints between the wall and the windows to make this kind of joints. Traditerm joint treatment profile to cover the joints, the structural joints of the building. And Traditerm crowning profile is a profile we place in the top part of the system to protect from the rainwater. So combining all these components and complements, we design different versions of Traditerm system. The first one is Traditerm EPS XPS. It's the basic one, is the most common used one. Here in this version of the system, we are using Traditerm or Traditerm projectable as a mortar for fixing the panels and for covering the panels. We are using EPS and XPS panel, EPS or XPS panels for the thermal isolation. And we finish the system with our Mortencryl Fondo and Mortencryl or Mortencryl Mosaico. The second one is Mortencryl Traditor Mineral. It's the same as the Traditor EPS XPS, but we are using mineral wall panels instead of EPS or XPS panels. Here we obtain this fire resistance we may need in several projects. The third one is Traditor Flexible. We will use this version of Traditor system when we expect our building is going to suffer high attacks from weather in big changes of temperature, or we expect the structure of the building can have little movements. So we use this flexible version of the system to absorb, to avoid crackings or problems from these little movements. In this system, we use Traditerm as adhesive to fix the panels. We use only EPS panels in this kind of system, and we render the panels with Traditerm Flexible. And the finish will be done with Fondo Mortencryl and Mortencryl Flexible too. And the last one is a version of Traditor EPS system, but with tiling as a finish. So we are going to finish the system not with acrylic mortar, but with tiles. We will use a special adhesive for this application called Traditor Ceramic, and to improve the adherence, to avoid problems the cooling of tiles in the future, we are going to apply a double layer of Traditer mortar before the finishing. So we have a double application of Traditer with mesh, and after that the finish with the tile. All these systems, all these versions of systems, and all the components of the systems follows the European standards. The IOTA is the organism which controls the quality of these kinds of systems in Europe, and the ETAE is the document which certifies all the properties of the system for the thermal isolation and all the characteristics of waterproofing, breathability, and all the other characteristics. All the components are also follows the European standards for the different kind of mortar or the different kind of material we are using. In addition of these characteristics of these products and components and systems, Pidilite Grupo Puma offers several services to the Indian market to complement the system itself. We have a very trained technical team which works both in our R&D department, developing new finishes of the system and looking always for how to improve the characteristics of our thermal isolation systems. We have also a specialist in application team who give all the professionals enveloped with the installation of these kind of systems, the assistants, the work assistants, so they can explain the technician which version of the system is the most adequate for the application or for the project they are developing, or any assistance they need in the design of the system. And we are also applicators which can help and assist the people who are going to install the system in the building about how to do it in the best way for not having any problem. As this kind of system have been applied in Europe for many years, we have a lot of projects done with our Traditan system, and we have documentation about all these projects. We have technical reports where we have all the information, technical information of the different projects made with our system, and this information can be used for the technicians who are going to use to include our system in their projects. We have also constructed the tiles and BOQs and a lot of information and documentation to help to make the technicians' work easier when they decide to install this kind of system in the building. And I wanted to show you some examples of buildings applied where they have used this kind of system. So you can see different kinds of buildings where it can be used, different finishes and different materials of isolation panels can be used in this project. And that's all. I hope it has been interesting for you. Thank you very much for your attention. And if you need any other information about this or any other product or system of Pidilite Grupo Puma, you can contact us in the email you can see in your screen. Thank you very much for your attention, and see you soon.
Good afternoon, professionals. My name is Samir Sullakar. I belong to construction chemical industry. I complement CIDC for this India Construction Week 2020 with the aim of revival of economy. We are largely dependent, or we are directly dependent on construction industry, as we are manufacturing the construction chemicals. I shall give you a brief introduction of construction chemicals, the industry overview, some efforts, some problems that we are facing, and some efforts that we have already done to revive it within our limited means during this pandemic times. This is the basic agenda, the introduction, the industry numbers, the key trends, the action taken, and conclusions. Construction chemical industry is a industry basically which manufactures construction chemicals with the whole purpose of solving the problems during the construction, during the surface life, and even going to the stage of repairs and rehabilitation. So we are connected to each and every stage of construction per se, and our aim is to increase the durability of concrete, which is also proportional in a way to the sustainability, and to improve the constructability. Whichever type of concretes are required, which are not possible to do otherwise, we use chemicals to make the constructability and the construction more viable, more green, and more sustainable. We are categorized in specialty chemicals. We are civil engineers, or we are engineers who know about chemicals, and we are chemists who know about concrete. We devise the solutions. In fact, this industry grew from the solutions. Those are asked of us by the construction industry. They wanted a self-compacting concrete, so we had to give them a concrete which compacts by itself. So we have to go in and manufacture that particular chemical which aids the making concrete self-compacted. Ultimately, the whole aim is to make the concrete more sustainable, more durable, so less recycling, so that the environment is protected. Our expertise, as I said initially, is a concrete enhancement. We help during construction, concrete repair, when the concrete is exposed to difficult conditions, we repair the concrete, and to avoid the repairs and to make the concrete durable, we have got third and the most important function is the concrete protection. Traditionally, we are sandwiched between two big industries. On one side, there is the construction material industry, like cement, minerals. This is a very large industry, the large players. And then there is a traditional chemical industry, which is also equally large, because all our raw materials, cement is also our raw material, minerals are also our raw materials, chemicals are also our raw materials. So in both the cases, all our raw materials, all our inputs come from large multinationals or large organizations. And we as construction chemical industry are basically, our technology is the formulation technology and mixing and blending technology. We provide solutions by combining these both things. So we are sandwiched between all big companies, and we create the values. We create the values. We create a value addition. We increase the efficiency of construction, so the construction becomes more economical. We increase the strength of concrete. So we make very small elements, very small dimension columns, and we can build, save a lot of space to the builders. We make the concrete beautiful. We make the concrete aesthetic. When you use construction chemicals, you also can get a good surface. So we can even go to the extent of making a fair-faced concrete, which looks very beautiful. It is gray and it is concrete. Safety, it is one of our most important things that we provide. We protect the structures. Protection of structures is very, very important in these times of pollution. And to reduce, to do a perpetual maintenance and to reduce the costs of repairs. Protection and maintenance are one of the very important steps that our industry should take to save the resources. We increase the span of the building by giving it protection or by repairing it, which increases automatically the life of the structure. So the life cycle costing becomes less. And most important is what we are doing very recently, I will not say very recently, but few years back, we are making the buildings energy efficient. We are having insulation systems which when applied to the construction can save your cost on electricity. It can reduce the temperatures in the habitat, in the living areas, and this is a large contribution. We save the air conditioning costs. This helps the sustainability on the whole. Just few numbers. As per some latest data which has been taken from internet, our market size is approximately 9,000 crores, 9 to 10,000 crores. The growth rate, which was supposed to be or estimated as 17% CAGR, due to COVID, it is little bit less, 9%. Hopefully, if we can achieve it, it is very good. There are about 500 to 600 players, known players, and there are still hundreds of more, which are not known, or we do not exactly categorize them because they make a single product, like a single waterproofing compound. The companies involved in construction chemicals are from a wide range. That means we have companies which are 100% subsidiaries of multinational companies, which are manufacturing construction chemicals all over the world. We have large Indian companies. We have large paint companies manufacturing construction chemicals. We have 100% Indian companies who are also manufacturing construction chemicals with their own technology. We have foreign collaboration companies. These are joint ventures between the Indian companies and the foreign companies. We have MSME and small scale industries in this sector. So what happens, this whole market is to be catered by all this type of companies having different constitutions, and that gives this particular industry a lot of difference compared to the other industries. Just to give a data, like the turnover of top 10 companies is about 50% of the total turnover of the industry. As far as the growth is concerned, and just to relate it with the global growth, from comparing the time era of 2015 to 2020, is a very big industry globally. It is some 120,000 crores industry, whereas in India it is 4,225 crores. This is way back in 2015. The growth rate internationally has been only 6.5%, 6.4% per annum, whereas the growth rate in India has been 13% per annum. In 2020, we have reached worldwide about 180,000 crores, whereas in India, we are about 9,000 to 10,000 crores. That means we are growing much more than the other world. The reason being, we are still an economically developing country with sound education, very good resources, whereas other countries like in Europe and America and all, they're more or less stabilized. So this industry is called a sunrise industry. We have got a lot of growth potentials, and there's a wide gap to be achieved between what is really the industry is and what the industry can go to. This has brought in a lot of foreign players as well as the Indian players, and the industry has seen some significant mergers and acquisitions and takeovers of the existing Indian companies. This trend will continue in the days to come, because as the market grows, the larger companies will like to be a part of the game or the part of the industry. And in about 2025, we are hoping that this market capitalization will be about 15,000 crores. The effect of COVID on the whole numbers, because these numbers are coming from a particular private source, which is also available on the net. It is a study of the construction chemical industry in India. It may change slightly or considerably depending upon the length of the conditions we are having. These are the market segments, global versus India. Just to give one or two examples, the consumption of admixtures in India is about 40%, 39%, whereas the consumptions in India is out of India is 26%. This shows that our construction industry or our constructions are growing with respect to what is going on all over the world. Our repairs and rehabilitation is about 10%. Still, it is on the lower side. It should be more. Whereas internationally, it is only 2%, which also means our structures are not that well protected as compared with the global industry. I think this comparison will really lead you to find out where are the gaps in the industry and fill it. As far as the products are concerned, as far as the growth of industry is concerned, flooring, similarly, to come back, that our floorings are about 9 to 10%, whereas international flooring is only 2%. Once again, shows that our industrialization, flooring mostly goes in the industrialization, is far more than the other countries. That is, we are a growing economy, and we have a lot of prospects for the growth of construction chemical industry. Segment wise, about 24% go into commercial buildings. We are dependent on real estate. About 31% materials go to the residential. So this is quite a big sector. So if this is reduced, and the public buildings is about 3%. So this constitutes to about 34 plus 24, about 68%. So if the buildings and the real estate industry takes a hit or goes down due to this economic conditions, our industry will take a direct hit. The infrastructure takes about 27%. Fortunately, we are very strong in it. The projects of building our national highways, our national resources, metros, and dams and other hydroelectric projects is going on uninterruptedly. And this is a very, very positive thing. This industry can contribute tremendously to this infrastructure and the growth. Few trends: the rising consumption of the population. We have schemes from government, PM via Awas Yojana, which will give a lot of housing, which will directly benefit, indirectly benefit the construction chemical industry. There's urbanization. There is a trend that the people from villages are slowly coming to the cities. So with this urbanization, new structures will come, new markets will come, new infrastructures will come, which will lead to a growth. Resource utilization, compared to other parts, India is a very, very vast area country, and the land covered by construction is very less. It's about very, very less compared to other developed nations. A lot of investment is coming into the IT industry, as well as a lot of investment is coming in the health industry. Every industry at the end of the day will need construction or needs the constructions. And that is the advantage of our industry. In whatever constructions, our industry has got an entry inside it. Growth drivers: increasing investment in infra projects, growth in urban housing, increase in FDIs leading to the boost in industrial sector, repairs of the existing infrastructure. This is a tremendous market, unbelievable market. And if we start taking the cognizance of these repairs to retain the durability to increase the life enhancement of our civil engineering assets, this would contribute tremendously to the construction chemical industry. Where regulatory environment for the environment is there, and increasing compliance with we are playing with the international players, so that too is a growing trend. There are limitations. Which are the limitations? Limitations, as I said in the beginning, that our industry is sandwiched between the giants, whether it is for the cement, minerals, or it is for the raw materials. So we are in between. Our suppliers are top level companies. So we have very less control on raw material pricing. When we are selling to the larger companies, they have the tremendous bargaining power. They need tremendous terms for financial terms in terms of credit, and we have to provide it. Whereas the industry, as I said, ranges from multinational companies to MSMEs. So this is one of the very restraining factor. Credits and payments. Now this brings us into especially the small players. This brings us into the uh, cash flow troubles. Then there's a competition from unorganized sector. Unorganized sector is a sector which is neither they are members of our associations, nor they are in the mainstream, but they manufacture some one or two products, and purely by virtue of their personal contacts and purely by virtue of their pricing, they still enter the market, and they keep on growing. There's a lack of awareness. The customer is not very much aware of the type of the materials and where they are to be used, and this is a big restraint which we try to fill up. I'll just come to it. And lack of adoption based on the price concept. This is one of the main things. These are the challenges which we met. How we met them. The main challenge is the low barriers to entry. With a small capex, with a small capital investment, you can start a construction chemical company. Many of the people who were initially working in the construction chemical, they got their own factories. Many of our raw material supplies, like that of sand, they are now the manufacturers. There is lack of skilled manpower, which I think our CIDC will be covering in the skill development. This is very important. It's a highly fragmented market. It is going from villages to the cities. We have low base material consistency. If we don't go to the multinationals and if we go to the local suppliers, then the consistency of the materials is not there, leading to not very good product at the end of the chain. There's a high price sensitivity. Everyone is bothered about money. There are auctions. There are ways where people want to reduce your pricing to minimum. And there's a low acceptance of high-end systems. This is very important. People are not very keen to calculate the pricing on cost cycle. People are more interested in calculating price of the initial price, per kilo price, not considering the durability, not considering the length of the time the material is sufficient. So we did overcome the challenges? We made attempts to build awareness, work in partnership with maybe small companies, make them partners by getting materials manufactured from them, drive the specifications higher to be a part of the codes, to part of the government committees, and therefore contribute so that the standardization comes directly from the top, and to leverage the core expertise. To this effect, we formed an association called Construction Chemical Manufacturers Association way back in the year 2012. This is an association, this is an apex body which represents most of, but a very small portion of the construction chemical manufacturers who are really interested, in coming to a forum. In coming to the forum, they are really interested in making the product as per the international standards. They are really interested in being part of the industry to bring in awareness. So we have about 60 members. If you see the top names will be the part of the organization. So these people have been already working for past 7-8 years, and Construction Chemical Manufacturers Association have done a lot of efforts to bring in the awareness, whether by means of presentations, whether by means of webinars, seminars. These are the actions which we have taken. Training programs for the end users, training programs for the construction chemical industry so that they become aware, tie-ups with professional bodies for documentation, conferences, seminars, national and regional. We have done both of them, working with BIS, CIDC, Engineering Council of India, development of codes of practice, which is coming slowly, but still it is coming. We are getting standardized. Development of handbooks. Indian Concrete Institute has done a tremendous efforts, and now the handbooks on admixtures and handbook on waterproofing is almost seeing the light of the day, and we already have handbooks in ECI on precast in ICI in precast construction as well as industrial floorings. So a lot of work has been done by the professional bodies, and this standardization is coming. Creation of awareness slowly compared to 20 years back or 30 years back when I entered the country, the awareness level is today quite high. And industry standards are also increasing. The international players are coming in, international standards are coming in, and hence more and more standardization is coming in, and the acceptance of the high standard products is more acceptable as of today. So we are learning what we are learning, or what are the conclusions? We are a part of the construction industry. We can affect the sustainability and durability. We can bring the speed and economy and eco-friendliness. Needs still more efforts in increasing the awareness. It is a mature but slowly expanding industry. We should directly go into the specification. It needs a better further organization. We need a stronger organization. Many more people to come and join this movement. More increase or faster codal developments and handbooks. Academics and professional training. This is coming up in a very, very nice way. The IITs and the other top level bodies, they are trying. AICTE is involved. CIDC is having skill developing. So this is going on. Of course, we need a government support at the end of the day. To bring in more standardization, more awareness, and as we said, and as I mentioned to start with, to sum it up in the conclusions, we will need a lot of support from the government with respect to the liquidity, with liquid to standardization, with respect to the skilling, and in addition to all the efforts that we are doing, help from CIDC, help from ECI will be very much appreciated. We shall definitely come out of this times. And once again, I thank CIDC for making this initiative to revive the economy in these times. Thank you.